Okay, today's learning goal, by the end of today, I will be able to add and subtract mixed fractions. So we're going to deal with both adding and subtracting. So we'll start with adding, and we'll do a couple demonstrations just to get the idea of what we're going to try and accomplish. So this is 3/4 plus 1/2. So when you look at this problem here, the biggest thing you should take away from this is that these are not the same size pieces. So you can't add or count these up because they're not the same size. And that's the main driving factor in adding and subtracting fractions. We need to have the same size piece. So what we do is instead of using a half, we bring down our quarters and we change our half into quarters. And now that we have the same size pieces, when we go to add these together, we can just count up how many quarters there are. So what that looks like over here is I would have 3/4 plus, now instead of 1/2 I use my equivalent fraction to get 2/4, and all we have to do is count them up. 1, 2, 3, 4. There are 5 pieces, and here's the key, that are all 1/4 in size. So we would write it like that. Now if we wanted to turn this into a mixed number, you can see pretty quickly, if we stack this on top, I would have 1 whole unit and 1/4 left over, and this would become 1 and 1/4. Okay. All right, so let's try it 1/2 plus 1/4. So again, we don't have the same size pieces, so we have to make some quick changes. So if we turn this 1/2, like we did in the previous one, into quarters, then when we go to write our expression, it becomes 2/4 plus 1/4. And again, the numbers on top tell me how many, and the numbers on the bottom tell me what size those pieces are. Okay, so in this case we have 1, 2, 3 pieces that are all 1/4 in size. Okay, we can add up multiple terms. So if we have a half plus 1/4 plus 1/8. Now in this one I don't have the easy half/quarter switching, but I do have this eighths involved. Okay, so what I'm going to do is I need to make all of them the same size pieces. So I can try this, where I change my half to quarters, but now that doesn't include the eighths. What I can then do though is take the eighths and start covering up the quarters. So what we're finding here is a common size that all of the original pieces can be changed into. Okay, so if we look at that now, the original 1/2 became 4/8. Come on. The original 1/4 became 2/8. And the original 1/8 we just leave alone. And again, so the numbers on the top tell me how many. So if we count them up, 1, 2, 3, 4, 5, 6, 7 of the pieces, and the pieces all happen to be 1/8 in size, so this is 7/8. Okay, so we wanted to do the same type of problem with fraction circles. We would just take some of these away. So you can see that the half turns into quarters, eighths, and then the quarters turns into eighths, and if you just count them up, you'll see there's 7/8 there, and there's one missing piece. So it's the same idea, only with a slightly different picture. So if you don't like fraction strips, circle's another option. Okay, so now 1/2 plus 1/3. Now see, this one's a little trickier because 2 and 3 don't go as easily together as 2 and 4, or 2 and 8. Okay, so this one here we actually have to find a middle ground, or a shared piece that both 1/2 and 1/3 can change into. So in this case we're going to take 1/6. So 1/2 can become 3/6, and 1/3 can become 2/6. So this becomes the new challenge, as we have to find numbers that are shared between both fractions. Okay, so we're using equivalent fractions to change the originals. So this one up here was multiplied by 3 top and bottom. This one was multiplied by 2 top and bottom, and it makes this denominator number the same, which is the same size pieces. Now I just have to count them up. 1, 2, 3, 4, 5. If you add the numbers on the top, you get your 5. So we have 5 pieces that are 1/6 in size. Okay, so before we can add fractions together, it's important to make the size of the pieces the same. This is called finding a common denominator. That's the fancy way. We find a common denominator by using equivalent fractions until the bottom terms are all the same. Okay, so the key is getting the bottom terms the same. So if we have something like this, 3/4 plus 5/8, there are a lot of options we can use to get the bottom numbers the same. We normally try to keep our numbers the smallest. So if I looked at the first expression and I multiplied top and bottom by 2, I would get 6/8 plus 5/8, and I would have 11/8. Now, that may not be the first thing that comes to mind. Okay, we could also multiply the first term by 4 and the second term by 2, and this would give me 12/16 plus 10/16. And this is still a true statement. The numbers are just a bit bigger. And if I add these together, I have the same size pieces, so I would have 22 pieces that are 1/16 in size. And you might be saying, well, hey, those aren't the same answers or same numbers. And I would say, well, what if we reduced this fraction to lowest terms? So if I divide top and bottom by 2, this drops down to being 11/8, and lo and behold, they are the exact same number. Okay, so it doesn't matter if you use the smallest denominator, you just need to find a number that works for all of the values in the question. It just happens to be a little easier when you find the smaller numbers. So if you look at something like this, denominator possibilities could be 2, nope, no, 8 and 16 don't go into 2 very well. 8, well, 2 and 8 go into 8, but 16 doesn't fit into the 8 evenly. 16 would work. 2, 8, and 16 would all go into 16. 32 would work. 48 would work. 64 would work. Those are all numbers that could be possible denominators. Now we're going to use 16 because it's going to keep the numbers the smallest. So 1/2 would become 8/16. 3/8 would become 6/16, and then I don't have to change the last one. It's just 9/16. Count up the number on top. We have 9, 15, 23 pieces that are all 1/16 in size. And if we wanted to, we can do that division. One group of 16 fits into 23, and there are 7 pieces that are left over. Okay, so now I like to show this just because there's multiple ways to solve the problem. We have 3 1/4 plus 1 1/2, and I'm going to call the first strategy pieces. So I turn my 3 1/4 into something that looks like this. Okay, so all I've done is I've blown up the mixed fraction, and this allows me to just combine the whole numbers. So 3 plus 1 is 4. And now I can do the fraction piece separately. 1/4 plus 1/2. Now I'm going to take this and use an equivalent fraction for 1/2, and I'm going to turn that into 2/4. And now I'm going to just combine what I have left. So I have 4 whole units, and 1/4 plus 2 more quarters is 3/4. Okay, so that's what we call a pieces approach. You can blow up the fractions and then just work with whole numbers and then with fractions. The improper approach is an interesting technique. Okay, and it will become a lot more popular as you expand your fraction knowledge. So if I turn these into improper, okay, and there's a little pattern here. We have 3 groups, 3 whole groups that have 4 in them each, plus this one extra. So if we were to draw that picture, there are 3 whole groups with 4 in there, plus 1 more. So this becomes 13/4. Plus this one over here, 1 1/2 is 1 full group, plus 1/2, that becomes 3/2. Okay, and now I'm going to use my equivalent fractions. I can see I want to get a common denominator of 4 here, so this is going to become 6/4, and then when I add that together I'm going to get 19/4. And now your question will be, are these the same? Well, how many groups of 4 fit into 19? Well, 4 full groups of 4 fit into 19. They total for 16. That leaves me with 3 out of the 4 necessary to make one more whole group. So you'll notice I get the exact same answer. Okay, now subtraction fractions. So the principle is very similar. So if we start with 3/8 and I want to take away 1/8, I'm going to grab this eighth. Whoops. Grab the eighth here. Grab this eighth, and then I'm just going to delete it. Doink. So because I had the same size pieces, 3/8 minus 1/8 is just 2/8. Now what we might notice is this is not in lowest terms. So if I want to divide top and bottom by 2, this becomes 1/4, and I can turn this 2/8 here turns into 1/4, and they are equivalent. Both answers would be correct. Okay, 3/4 minus 1/2. Okay, so out of this 3/4, I want to take away 1/2. So 1/2 looks like that. Okay, so if I take away those two terms, not just this guy, so if I take away these two terms, I will have my answer. Okay, now what did I just subtract? I subtracted 2/4. So what does that look like from a writing standpoint with our numbers over here? 3/4 minus, now instead of using the 1/2, I write it in terms of its quarters. Okay, so 3/4 minus 2/4 leaves me with 1/4. So you'll notice the top numbers still interact just like we did with adding, only this time we're subtracting, but the bottom number doesn't change. It's the size of the piece, so we leave it alone. Okay, so 1/2 minus 3/4. So when you look at this, I don't have any quarters on this 1/2 on the fraction strips. If I could convert them into something that's measured in quarters, it would be a lot easier to subtract 3/4 from there. So there's the 1 turning into 4/4, and here's the half turning into 2 more. Okay, now from there, if I want to subtract 3/4, I would subtract, whoops, I need my pen here. I would cancel off 1, 2, 3/4. So my final answer here should be 3/4. So now let's look at what happens to the numbers. Okay, we might turn this 1/2 into an improper fraction of 3/2. You don't have to, it's just one option. If I get a common denominator now, so I'm going to multiply top and bottom by 2, I get 6/4, which is what you can see over here on this picture. And then 6/4 minus 3/4, we're just working the operation with the top, and you'll notice the bottom numbers stay the same. So 6 minus 3 is 3, and my bottom size is 1/4. Okay, so 3/4 minus 5/8. So again, we're not going to do the pictures on this one, but we want to try and get a bottom number that's the same. So possibilities could be 4, 8, 16, 32 maybe. So out of all those 4 that I've just provided, the only one that doesn't work is 4, because 8 doesn't fit into 4 nicely with as a whole number. But everything else can go into 8, 16, or 32. Now I'm going to use 8 because I want the smallest value. So I'm going to convert 3/4 into 6/8, and then I'm going to subtract 5/8. Now I have the same size pieces, the same denominators, so I can go 6 minus 5 and end up with 1/8. Okay, so again, 3 terms. We want to try and find something that is shared between all of these. We did one previously, so we should be comfortable with 16 being the target. So I can turn the 1/2 into 8/16 minus 1/16, and then turn the 1/4 into 4/16. Okay, so now we have the same size denominators on all of these, so I can subtract the numerator. So 8 minus 1 is 7, minus 4 is 3, and the size of the pieces doesn't change, so the answer here is 3/16. Okay, now you can do the pieces and the improper approach with subtraction. You just have to be wary of one little piece. No pun intended. So 2.5 looks like that, but this guy right here becomes -1 and -1/8. That's really important. Okay, most people put a plus sign in there and then it doesn't work. So these two here, 2 minus 1, they can be combined to just be a half, and then you have 1/2. Sorry, a 1 whole there. 2 minus 1 is 1. Jeepers. Half minus 1/8 is our next problem. So I'm going to use a common denominator of 8 and change this to 4/8. So now I have 1 whole unit and 4/8 minus 1/8. That leaves me with 1 3/8. Now if we do this as an improper fraction, okay, so we have 2.5 minus 1 1/8. I have two full groups of a half, so a little shortcut is we multiply these guys and add this one on. So 2 times 2 is 4, plus 1 more is 5/2. To convert the 1 1/8, we multiply these guys and add. And if you want to go back and look at the equivalent fractions for a quick refresher on why that is. So this becomes 9/8. Now I want to have equivalent fractions, so I'm going to multiply this side by 4. So I end up with 28 minus 9/8, and that leaves me with 11/8. Or, and how many 8s fit inside an 11? One full group of 8 fits inside 11, and I have 3 remaining or left over. And you'll notice I get the exact same answer. Okay, so if you want to pause it and try this one, and then I'll take it up really quickly. Okay, so here we go. 3 plus 1/4 minus 1 minus 7/8, 7/8. And you might find one technique is better than the other, depending on how you like to approach the problems. So 3 minus 1 is 2, and now I have 1/4 minus 7/8, and I'm going to run into one really nice problem here. So this is going to become 2/8, and when I go to subtract these, I'm going to have 2. Now 2/8 minus 7/8 is -5/8. Okay, so this is one of those interesting ones. We're taking away more than what we have, so we go into the negatives. Now, if I want to continue with this problem, I'm going to have to break this 2 down into 1 plus 8/8, then minus the 5/8. Okay, so this guy right here, this 2 became 1 plus 8/8. Okay, now I have some fractions. I can finish this problem. So I should have 1 whole unit and 3/8 left over. Now that gets a bit cumbersome, so you may not like that approach, but let's see what it looks like from an improper standpoint. So if we have 3 1/4 minus 1 7/8, if we do the multiply and add, this becomes 13/4. Multiply and add, this becomes 15/8. If we get an equivalent fraction, so this becomes 26/8. Now I have 26 minus 15, that is 11/8. And you'll notice I get the exact same answer. And to me, I find that method a little easier. So for me, I usually solve my problems with improper. Yes, you generate some larger numbers when you do your equivalent fractions, but there's not a lot of this balancing, re-breaking down strategies you have to do with if you work with pieces. Okay, so there you have a task for adding and subtracting fractions. Thanks for tuning in.